Okay, hello guys. I'm sorry, I will set something up first. Alright, welcome again guys, everybody, to VR Training 101. And today's course lesson is all about 3D interaction in VR. And once again, my name is Anjara Ditya Pratama. I am Unity Certified Developer and I am now lead VR developer at Sinta VR. And I also active at Indonesia Virtual Reality Association on research and development team. You can contact me or hang out with me on my Facebook. You just type in Anjara Ditya Pratama, or you can see or you can email me at aditya.pratama2910@gmail.com, and you can also see my LinkedIn profile down below. All right, before we start, just like the usual, the requirement for this course is, of course, the software one is we need to have a Unity installed. The next one is we need to have Visual Studio Community, which is available within Unity installation, and we also have Android Studio and Android SDK, Java GDK, and Google VR plugins. And the skills that we good to have is Unity interfaces and C#. So today's agenda is quite not too much compared to our previous session, because today we will learn about 3D interaction, and I want we can really go deep into these topics, because this will be our foundation to develop any 3D application, including VR, and maybe some of you guys interested in game development and AR and something like that. So the topics is containing about the first one is we will overview about our Learn API from our past session, and then we will continue to learn about Transform API, which is we will learn about Position and Rotation API within Unity. So we can start to modify our position, our game object rotation and such. And then the next one is we will learn about Transform API more deeply. We will talk about child and hierarchy. And then the next one we will learn about how do we play or we create video player using Unity. And if you see nowadays we have a 360 video, and we will learn about that as well. So, and the next one is we will create game object in the runtime from Prefab. So we will learn about how to create the template of our game object, and we want to spawn it into our games in the runtime. And then the last one, we will learn about raycast and layer concept in Unity. The total of our session is around 110 minutes, but we will learn it each step by step more slowly, because we have a lot of things that we need to cover. So let's get back into Unity. In the previous session, you might see our screen or our scene something like this, but maybe to refresh our mind, let's create a new scene like on. So you can create a new scene using File New Scene or Control N, and you will be served empty Unity scenes. So today we will learn all about scripting or making behavior for our VR application. So for you guys, let's create a script folder. I already have my script folder in here, and let's create our first script. And we will overview or review again our learned API before, which is a game object. So let's create this script real quick. Let's create this script called review. And let's create our cube. So Where's my cube? Okay, this one. So let's learn from the start. So we already learned about how to activate and deactivate our script, or I mean our game object. So the first thing that we need to have is the reference of our game object, which is we can create a public game objects. My game object. And we already learned about how we process our input using input module in Unity. So we learned about input.get key down, which is when or what key that is currently is pressed within our games. So input get key down key code dot for example A. Yeah, this means this will check if A key is pressed down or not, and we can add the if keyword, and we can just create our code in here. So for example, I want to make our game objects disappear. When we're using key A, and I want to make it shown again when we press, for example, space. So this one is really simple. Just type on our reference of our game object, my game object dot set active. So the first one we want to review is set active function, which is will make our game object is active or not. So if we want, if we press the key code, or I mean the key A, we want to make our cube is disappear, which is our active flag is false. And we want to do the otherwise when we press the space bar, and we can just copy and paste our script and change our true or for our false parameter to true. So if we save it and let's back to Unity, and let's create an empty game object to hold our script, and drag and drop our game objects tutorial. As you can see, my game object properties is exposed, and we can just need to drag and drop our cube to that. So once we press play, and when we press A, as you can see, our cube is inactive. So if I hover my selection to the cube, you can see this one is the this one is active state of the object, and it currently is not checked on, and it means the game object is inactive. So when we press space again, the cube will be active again, just like you can see in our script. When we press A, we want to make my game objects, which in this case is cube, to the false flag. So, and then when we press space, we want to make our cube is active. So we can back again to the Unity, and we can press A space, and you can see our cube is disappearing and appearing again and again. So that is our first review, and then the next one we want to learn about how to modify our game objects transform. So in Unity, transform means just a representation data or a data that represent our game object position, rotation, and scale state. So if we just select our cube in here and make it bigger so you can see more clearly, you can see our cube have its position to -0.7, y is 2, and z is -3, and then the rotation is all 0, and the scale is all 1. So if we can just change it to 0, 0, and 0, as you can see in here, our cube is moved to the zero position in the unity state or in the unity world. So if I press the button in here, so we can see our cube from above. As you can see, if we move our cube using the handle, for example, to the right, the transform value of position X will be changed. So you can see this one is moving. If we press, we handle it to the left, it's become negative, and we press to the left or to the right, the position X become bigger. So in game, we want to make this kind of position change using our input module. So the first one we want to learn is how to move our object. So the first one, we just comment our script for now. And let's learn about how to move our script, our game object, I'm sorry, through the script. So let's learn about input key. So just like in the simple game, of course, if we want to move forward, usually a game is using W, right, to move it forward, and S to backward, A to left, and Z to right. So we will just follow just like that. Let's say we have already input A, and we need to define 3 more keys. So we just copy it and paste it. We need only this one, and can paste more to the our desires. So we want our script to active listening to A key, W key, S key, and D key. So to transform our script, we need to use the script API called transform.translate. So we have my game object, and we can just, for example, we want to make it forward using the W. So we can just press my game object dot transform dot translate. So you can see we want to translate our game object to the forward. So we can just press it to the vector tree and forward. And I think I have some question. Oh yeah, I'm sorry I forgot, guys. If you have some question within our lessons, you can chat on the chat box on your screen, so I can read it out and maybe I can reply to you as soon as possible. So let's get back to the lesson. And let's see, this one is our script to make our game object go forward when we press W. Let's get back to the Unity. And then you can see when we press W, you can see our cube is moving. So as you can see that by pressing W and our script is go to forwards more and go and on. And we can go back again to this script editor and we can just copy it to the S section, D section, and of course the lowest one is the A section. And we can pass the difference parameter, and in this case if we want to move forward you can just type the vector 3.forward, and if you want to move to the right, which is when we press D, you can just press vector 3.right. And on the when we want to press to left, and you can see maybe you have some ideas that vector.left. and then the S section is vector3.back. So let's save and let's back to the Unity. And as you can see, you can move your script freely using W, A, S, and D. So I want you guys to maybe save your time, or takes your time, I mean, to see the scripts. And this is literally script that makes our game object moving to some direction. So it is really simple. If you can see, our script is only containing the if input.getKey and our key code, which is in this case A, W, S, and D. And in the if, you can see this is only one line of code, which is my game objects, which is our game object. Dot transform, as we want to access the transform section or transform component, and we want to translate or move our transform with using a value, which is in this case is the left, or the shorthand for writing vector3 -1 on the x-axis forward, or the z-axis positive value, the back, or the z negative value, or the right, so using the positive x value. As you can see, when we press play again, see the cube transform component. As we want to press W, the value is moved or changed to +1, +1, +1, and when I press S, it's -1, -1, -1, and when I press A or D, the x-axis is changed. So the next one, we want to learn about rotation. So in Unity, you have three parts of in the transform, which is it's only a value that makes our game objects move around the 3D world. So if you can see, the first things that we learned today about transform API is positioning them, and then the next one we want to talk is about how to rotate them. For example, if we press this button or rotate tools, you can see this gizmo or this tools is changed, and we can see, or we can press this one to rotate our cube. So we want to make this change happen as we press some buttons. So let's just comment our moving direction code, or for our convenience, let's just comment all of them together. So let's create a region, which is this only is for folding our script. Let's say movement script, and this one we need to make it in region, and we can copy it first, and we just press this one, and we can forget about our movement script. And let's learn about our rotation. And just like our movement script, we want to make our game object rotating as we press some buttons. So the syntax is almost the same. The first one, we need to reference of our game object, and I want to access its transform, and we want to change their angel. So you can see there is a variable or field called Euler angels, and the definition of Euler angel, as you can see here, is the rotation as Euler angels in degrees. So, for example, we want to make our cube, or we want to make our cube rotate, for example, when we press A to the left at 45 degrees, for example. So we can just add our Euler angels, which is vector 3, 45 degrees. So the syntax is plus equals, and we create the vector 3 variable, and we can just pass negative 45 on the y, on the y float. So let's make it something real quick. And as we can see, we can drag and drop, and we can go back to our Unity. And let's press play. And when we press it, as you can see, it's rotating up, but it's some weird way. So let's add more script. When we press the S keys, we want to make our script is 45 degrees more, and maybe just that for now, and let's play. We'll wait sometimes when you see this is a blue button, Unity is already finished compiling our script, and you can see when we press A and S, the script is moving, but in weird ways. It's not just like our expectation. And let's see if I do something wrong. My game object transform the Euler angels. Okay, let's make it local. Oh, it's still the same. What's wrong with my cube? It should just rotate it like this. Or, for example, you can press. Maybe this one will be more good. I'm sorry, some of you guys have some audio problem, maybe. Okay, now it's gone. I'm sorry. I hear a lot of high-pitched audio previously, and I kind of lost my focus on. I'm sorry, guys. Okay, let's back when what we left. What it's again? Oh, rotation. Okay, we want to make our cubes is rotating just like this. As you can see, our cube, when we press this one, this axis, our cube is rotating just like this. You can see. And we want to make it like this on our script. So first thing first, we want to make our script. We want to call our game object, which is my game object, and we want to get the transform reference on it, and we want to have our rotation. It should be like this, or rotate. We want to make it a rotate method. I think applies a rotation of Euler angle z degrees around the z-axis, Euler x degree, and blah blah blah. Okay, let's use these methods first. So we want to make, for example, let's back to Unity. We want to modify our y rotation. So let's just pass other than else as 0, and we want to press or give the y-axis 45 degrees and the 0 on it. And let's press play. It's kind of hot in here. Air video. It's still moving like this. I'm wondering why. It should be the position need to be like this. But why in the world we rotate the cube like that? Okay. Rotate. Applies this one, space. So we need to pass some space though. Applies relative to the word. Oh, still moving like this. Maybe it is self. It's kind of weird because we want to make our cube rotation just like, sorry, maybe I forgot to comment it. Oh, of course. Oh, of course. Of course. Yeah. Some mistakes I have in here. I'm sorry for some confusion, guys. So I forgot to comment our previous code. So this will, well, actually this will makes our script, the first one, our game objects is rotating, or we tell the Unity to rotate our game object, and then the next one is we kind of tell the Unity to move our script to the left. So the weird part of that is because of that. So yeah, can just delete this one, and as you can see, you can copy this one and negative. I'm sorry, it's not S but D. And then yeah, you can see as we can press play again. Yeah, as you can see, our cube is moving. Maybe if 45 degrees is kind of hard to see, let's just make it 30. Yeah, so you can see right now our cube is kind of rotating on the y-axis to the right and to the left as I press A or D button in our game. So yeah, I'm sorry for my mistakes. that I haven't commented our script and executed by Unity, as we want to only rotate our cube. So maybe some of you guys is kind of curious that what happened if our script, our rotation script, or moving script is placed outside of the if blocks. So, for example, I want to create something like this. So what happened? So what happened is the script or our script will be executed every frame. So our script, or I mean our cube, is moving 30 degrees each frame. So if you have 60 frames per second, this will move the script 30 times 60 seconds. So for example, let's make it a smaller size. So we want to make the change of our rotation to only 1 degree to each frame. So as we can play, as you can see, I press nothing and our script is kind of rotating by itself. So before I forget about renaming it again, let's make some comments. And this rotation script makes our game objects rotate at some direction. So to review it again, my game object, which is the reference of our game objects, dot transform dot rotate. So we want to rotate our game objects to some degrees at some axis, and in this case we want to rotate it around y-axis. So yeah, let's save our scene for now. We can do it for using file, save scenes, and we can create our scenes again and maybe name it transform API tutorial. And then maybe we want to open some more cute scenes that we already have in our section. So now let's learn about other API that commonly be used for making the 3D and 3D behavior. The next one we will talk about look at. For example, we want some of our game object, for example maybe this deer, to look at us every time. So for example, this one is us or our player right now. So if our player is somewhere in here, we want to make our deer moving or see us like this. And if we, for example, move to this one, and we want to make some rotation to our deer, for example, you can see we want to see our deer looking at us like this. And if we use the traditional way, we need to have our deer rotating at some degrees facing up our player or our eyes. So in Unity, we have some script or API that we can use, it's called look at. So let's make our game objects already, and we can see my game object transform and look at. So the script is the usage of the script is to mix our game objects, some game objects in our VR to look into our eyes. So as you can see, this method requires only one parameter, which is the transform of our target. So let's comment this script on before we do anything. So we will not make, or I will not make other faults like that or mistakes. And let's learn about lookup. We want to look at our targets. So we want our game object to see us. So to instruct the Unity to do that, we want to call our myGameObjects.transform.lookAt. What object that this myGameObject will look at? Of course, our camera. So we can pass our camera, our main camera, and since they want to have some transform, we can give our main camera transform. So when we input this one, and we can press save. And let's give it to our deer. So here's our script. Let's drag and drop to our script. And my game objects is our deer. So let's just drag and drop our deer out it. And when we press play, you can see our deer is moving or see us directly to our eyes. And it might be kind of creepy, but if you move your camera, you can see our deer is strangely or creepily see us. And as you can see, our deer is keep staring at us. So that is the usage of the lookAt function from Unity. So look at some game object. So the next one that we want to learn about is how to let's learn about child and hierarchy within our Unity. Oops, I'm sorry. So for refreshment or refreshing our brain, I think first, or I think the first session of our course, we talk about Unity hierarchy. So in Unity hierarchy, we have some game objects, something like this, as you can see. You can press our game object in the scene, and as you can see, this one is deer, and deer is currently the child within or from a 3D game object. So if you can see the 3D, if we have if we move the 3D game objects, all of the child of 3D will move just like 3D did. So for example, let's move our 3D object, and as you can see, all of them is moved. But if we only move the deer, which is the child, the 3D, the other 3D will not move. So we only move the deer parts only. So that is just like the relationship between the parents and the child game object. So for example, let's create the simple 3D plane using cube, for example. So let's make our cube a little bit bigger by pressing, not 100, maybe 25, and make our scale is 25 as well. So we have this one, right? And let's reset our position to 0, 0, and 0. And let's disable our 3D first. And as you can see, we have some flat cube, and let's create another cube. And let's call it child cube. Reset it to 0, 0, 0. And as you can see, let's move it a little bit high so we can see it more, maybe 2. So just like this, for example, we want to move our cube. Currently this child cube is not a child of any game object, and as we can see, if we move our object, some value of this transform position is changed, right? But if this child is a child of some other game object, for example the cube, and as you can see now, the position is still the same. And when I press or change the cube parent position, and as you can see, the value is somewhat changed, the Z position. But if you see the cube as well, the Z remains 0. This means every child or every transformed child, either its position, rotation, or scale, is relative to its parent. So if the parent is the one that we changed or we moved, our child position will not be changed because it is relative to its parent. But as soon as we change, for example, let's have some exact value on it, for example, -2. And you can see child cube is still 0, despite this cube is, of course, moving just like their parents. As you can see, the cube is moving. The child cube is moving with its parent. So, but the Z value of this cube is still 0 because once again, this transform value is relative to child cube parents, which is right now is cube. But when we change or we detach this cube or child cube from cube, as you can see, this child cube now of its position is not right now is relative to the world, this whole world unity position coordinates. So you can see this one is having -2 as well. So just like the cube. But if we change it again to a cube, make our child cube to be the child of the cube, I think it's really tongue twisting. But as you can see, the Z is going back to 0. And if you see maybe again, as you can see again, our cube scale is, of course, is 25, right? And you can see our child scales is 1. And when we make this cube, our child cube to be a child of this cube, you can see the scale is kind of blended into the cube because this parent cube scale is 25. So to make this cube scale to be 1 in the world scale or world coordinates, this will make child cube scales to 0.04. Why? Let's do some calculator in here. I'm sorry, I think some of you guys don't like math, but yeah, if you learn about code or VR development, well, you need or you will stumble upon some math. So, as you can see, this one is 25 and this one is 0.04. So 0.04 times 25 equals 1. So why our child cubes is become 0.04. It needs to accommodate the scale that cube parent is right now. So this one is 25. To make this child cube scale is 1 in the world coordinates, this child cube will need to rescale its scale to 0.04. So if we change it to 1, 1, and 1, and we can go back, detach this child cube, you can see the scale will be 25 because 1 times cube scale or parent scale equals 25. So if we want to make it scale is, for example, 2, for example, 2 and 2, and our parent is 25, of course 25 times 2 is 50. Something like that. Okay, maybe that is something that you need to consider about in working in 3D space. And I'm sorry too if I have or I make some of you is kind of a bit sleepy with some math course, but yeah, that's that. And then the next one we want to learn about is video player. So in Unity, you can play or you can insert your video. So for example, you want to play some video in your VR experience, or for example, you want to make kind of VR experience that when you press or when your user use your VR application, they will show you want to show them some TV, for example. So the TV content is of course a video, right? And you want to make it like you watching some TV. So let's create like that. So the first thing that we want to have, okay, let's create for some random reason that in this kind of forest we have some television. So unfortunately I don't have TV right now, and maybe let's search some TV in the asset store. So let's make it free. Is there any free TV? Oh, there is some stuff on it that it's free. Let's use this TV. Yeah, let's download it. Let's import it as well. And import. As you can see, once again, we will have flat screen TV folder once you import these assets. And you can maximize it, and you can see you have your flat TV screen right now. And for some obvious reason, we want to have our TV because it's quite big. Let's rotate it around, for example, and make it a little bit smaller. And yeah, we have some TV in our forest. So first thing first, let's save our scene and let's get back to some simple scene or empty scene to start from scratch. Let's create new scenes for now, and then let's learn about video player in Unity. So once again, almost all of the Unity functionality that you maybe stumble upon when you develop VR or games is called components. So if you click at component in it, as you can see, Unity is creating or developing some component for us to use. So if we want to create a video player, to Unity, you can just create some empty game object on it and just add a video component into the Unity, which is you can find on the video section and video player. And you can see video player has some of the properties that you might want to see. First one is source, which is on the main of this source is just the video source. So if we want to play from some video clip, maybe you have some MP4 files, for example, that you download from YouTube, you can use this source. Or maybe you want to stream your video feed from some browser, for example. You can just choose the URL if that is your needs. But for our current purpose and our needs is we just leave that default as video clip, and then the next one is video clips itself. So if you have some video MP4 or something like that, you can pass or you can give it to this variable. The next one is play on awake, which is the explanation is start playback as soon as the game is started. It means that once we press play in the Unity, the video will be played automatically immediately. The next one is wait for first frame. It means that if you check or enable this variable, it makes our video kind of wait until our video player itself is already finished loading our video. And if you unenable or uncheck these properties, this will make your video play immediately, but you will see some frame skipping. So it's kind of just like laggy effect or something like that. And then the next one is loop, and of course loop is only makes our video looping. So if after our video is already finished, this will make our video play it again. And then the playback speed is just like the speed of our video player plays, and this will leave us to default of 1. And if you want to make it a faster speed, you can change this value and up to 10. And we can set our playback speed to lower than 1, and you will make kind of slow motion effect. And then the next one is the render mode. The render mode means where our video will be placed on the 3D space. So we have several on it, but we will learn for now is these 3 kind: the camera far plane, the camera near plane, and then the render texture. And then the target texture will be available when we press or when we choose render texture. And if we choose the other option, the target texture will be gone. And then the aspect ratio mean that what kind of scaling process that we want our video to be played off. So for example, the first one is no scaling, which is Unity will play your video just like that without scaling some of your video. Fit vertically and horizontally makes our video will fit by vertically or horizontally. Fit inside to make it fit inside, and the fit outside to make it fit outside. And stretch makes our video stretch as just for example, yeah, the video will be stretched to fill your whole full screen view. So, and then the audio direct input is how our video audio files to be played. We can choose none to mute the audio. We can use audio source to kind of separate our video and our audio. And the direct is the default value, and API is not needed for now as it is still experimental. So let's play some videos. So for example, I don't have any video on right now, and maybe we want to have some video from YouTube, for example, just like for example, like what do you guys like? Asian games, maybe? This one. This is the official theme song from Asian Games 2015. Okay, I think I have some of it already downloaded within my files. So let's see. I'm sorry, I will open off some of my folder. Maybe we can wait for a minute. Please wait while I finding my video assets. Here. So you can see we have some videos, and we can just import to our script or our Unity projects by using drag and drop functionality. Let's create videos folder first, and then let's drag and drop our videos. As you can see, Unity will do some process, and here is our video. So we have some little preview in it, and if you press play, you can see our script, our video is playing. It means it is okay for now. And let's set up some video player right now. So as you can see, as like we learned about previously, that our source is indeed the video clip, since we have a video clip ready. And then the video clip itself is here. And you can just drag and drop to here. And then the first one we need to, or we want to learn about video player is render mode. So the first one is camera far plane. So if you see or double click the camera, you can see camera is viewing angle is like the pyramid shape. As you can see, this kind of big view, and it consists of two planes. The first plane is on the far plane, which is you can see in here. Like in here. This one is called far plane in the camera, and then the nearest plane within our camera is called near plane. As you can see in here. Where is our far plane? You might not see them clearly. You can see it here. This one is called near plane, and you might want, or you might change these properties using this one in camera. It means just the near plane is the minimum limit of how close a game object can be in between your camera. So if the game object, for example, let's set our near plane is kind of big, maybe for example 2, so you can kind of see the difference on it, and we can create a cube, for example. And make it bigger. Oh, where's my cube? Let's make it 0, 0, 0. And you can see this is our cube. So the near plane is in here. So if our cube is moving too forward or too close to near cube or near planes, the cube will not be seen or not be is not rendered. So as you can see, the cube is gone because our camera near plane is in here. So when we move our cube closer than that, our cube is gone, and it's the same as our far planes. So if we move our cube far enough, and let's make it bigger so you can see it more clearly. And if this cube is moving far beyond the far plane, you can see the cube is just gone like that. So this let's get back to the video player. When we means that render mode is camera near plane, it means the video will be rendered at near plane camera plane. So let's get drag and drop our camera on it, and when we press play, you can see our video is playing right here, and it is played on our near plane. And if we change it to the far plane, you can see there is no difference, but the video will be rendered if the near plane in here. But if you choose the far plane, the camera or the video will be rendered in this plane. So for example, let's create a cube again and make it somewhere like in here. If we press the make it near and we press, you can see the video. And when we choose the far plane, you can see video, but now our cube is seen because the video is rendered on the far plane camera in this part, and our video and our cube is in the way. So just like that, you can see if we choose the far plane, every 3D in front of the video will be rendered. But if you use the near plane, every video, or I mean every game objects will be gone because the video will be drawn in the near plane cameras. Alright, and then the next one is alpha. Alpha means the opacity of the video. So if 1 is opaque and the 0 is invisible. As you can see, our video is become gradually invisible. Okay, and then the 3D layout, we just make it none for simple video like that. And if we use side by side, you can see our video is kind of stretched out. So this will make kind of make our video is rendered side by side, and we will talk about that later on. And then the next one is the no scaling or aspect ratio. As you can see, previously we fit the video horizontally, So if you, just make it no scaling. And side by side is none. You can see when we choose our camera, our video is kind of too big for us because we don't scale it. But if we use fit horizontally, this will fit our video horizontally and vertically, or fit inside, fit outside, or fit scratch, which is this is just scratching vertical and horizontal. Okay, just like this. And of course, if your video has some audio data on it, Unity will show the track, and then there is a mute variable or mute field, and you can as well change the volume of our video. As you can see, we can play around with the video volume, and we can mute it, and it's effectively just set the volume to 0. So that is how you create or play video clip within the Unity. But the problem is, like again in VR is not have a screen concept in VR technologies, because we see not through LCD or not through the screen, we see through the lenses. And once again, let's learn about the last render mode that we want to use within our VR application, which is render texture. So instead of drawing our video using a clip or a near plane or far plane of our camera, our video will be rendered at a file called render texture. So render texture is just like a file that containing our texture in it, and the video is treated as a texture in the Unity. So for example, let's create real quick a render texture. How to create render texture is just like in our projects: right click, create, and render texture. And so let's create it and name it as video render texture. And you can see you can put your newly created render texture through the target texture. And let's have a quick glance of what is the video render texture have. The first one is dimension. The next one is size, which is what size of render texture in pixel, anti-aliasing, color format, depth buffer, and so on. But the variable that we need or we want to focus on right now is the size and the color format. So, for example, let's get back to the video player and let's play it once again. And as you will see, a video is playing. It's playing, and because you can see the sound is playing, right? But where is the video? The answer is rely on the video texture. And as you can see, our video texture is updating as our video change or play. So this means our video texture is just saving the current video frame. So what is the special of it? It means we can make our video as a texture of our game object. For example, if we want to change material or the color of our game object, we need a material, right? We want to create a material just like this. Right click, create a material. As you can see, just name it some my new material. It is enough. And drag and drop to our cube for now. And as you can see, our cube is now depending our new material to draw on our cube. So we can change our cube color, or we can draw our texture to our cube. For example, just like before. For example, we want to make our cube draw out some images that we have. For example, like this, we have some image of kind of triangle arrow like this, and we can make our cube texture to the particular images or texture. And render texture is just another texture. So we can theoretically drag and drop our video render texture to the texture. And as you can see, it is our video. So if we play our scene, instead of playing the video from or within our screen, it's just like play your video in your game object. Just like that. So that's how we create or we show our video within some 3D object. So let's get back to our forest scene. And we want to kind of watching some TV right now, right? Maybe it's our beer and our deer is love to watch some TV. And we can just maybe place them up like this one. And we want to watch some TV as well. And we can rotate it to make some things like this. And yeah. Something like this, and we can just do like the video or TV playing using the techniques that we already learned just like now. So we can just have our flat TV screen, and we can just create our 3D objects, and what can I say? The TV is flat, right? So we don't need a cube right now. We need a flat surface that we render our video like top or like on top of that 3D. So we need to create a plane instead of the cube now. So this is our plane. Where's my plane? So this is our plane, and we can just rotate our plane just like minus 90 degrees like this, and we can just move like this to be in front of your TV and scale it down to make it kind of fill your TV screen. And then the and mix our material to that plane. So just like that, we can just create an empty game object and name it video player, and add video player component, which is in video player, and make our video clip to the one that we already downloaded, and then make our render texture target to video render texture. So all things is set, and let's play our video. And unfortunately this is placed upside down, so we can just easily rotate things up like this. You can see, you can drag, oops, like this, or sorry, the value is just need to be changed like this, 90. Let's just 90, 90, and negative 90, just like that. And you can, and as you can see, let's maximize our game, and when we press play, we have TV show right now. And as you can see, our boar and our deer is love to see movies for us or with us. So something like that. And one more thing. If you see our screen or our TV resolution is not that good, so let's zoom it out for now. You can see this one is kind of blurry or something like that. It's because we haven't set up our render texture to match of our video clip. So as you can see and show in folder, and you can see right click to properties. You can see our video is 180 by 720 pixel, but our render texture, where is it? Our render texture size is only 256 by 256. It means like your video is converted from 720p to 255 or 56 pixel. So if you make it more smaller, you can see your TV will become more clunky, as you can see. And it's set, right? So let's just change our resolution same as our video. And as you can see, now we have some sharp images. Okay, just like that. If you want to watch the video fully, you can just you can just watch it on YouTube, guys. Okay, that is for the flat video player. So the next one is we want to make a 360 video player. So what is a 360 video player? Let's just jump into YouTube, for example, and let's create like that Asian Games 2007 theme song. Let's watch some conventional video. As you can see, this one is just conventional video. It's only rectangular video. And what is meant by 360 videos? It means the video it's not only flat, but it is a 360. So you can drag, you can see all of the screen is 360, or all of that, or all of our site is just video. It's 360. So if we play the application or play the screen video, you can see this is just like your normal video, but you can see all around us. You can see really, and there is a video everywhere as you see. So, yeah, the 360 videos is somewhat like that. So in Unity, it's just as simple to create a 360 video. It's just like we create this TV video player. But instead of using a plane as the render 3D, we create a sphere to it. So if you, for example, have some 3D ball or 3D sphere and make it a really big sphere, for example, just make it 50, for example, and set it to 000. As you can see, this one will be our base or our placeholder to play our video in it. So we just need to play the video inside of our sphere. So how to do that? First thing first, we need to learn or we need to create our video or download our video. Let's take a moment. I want to find my downloaded videos. Where is it? This one. Let's move it to the desktop, and as you can see, this is our video. Sorry. This one is our video. And you can see it's kind of weird, right? Because it's played on the plane surface. And we want to play this kind of video inside our Unity. So once again, let's get back to videos folder and import our 360 video folder, video maybe. And you can see this is our video. So Let's just create another material and another render texture. We name it 360, and we need to have the same render texture. Call it video 360 render texture, and make this video 360 render texture as an input for our video material, and make it sizes to 1280 to 720. And let's just make our sphere to have video 360 material placed on top of it. And if we play a video right now to 360 render texture, and then the video to Japan, this one, and when we press play, you can see our video is playing on the sphere itself. But the problem is it's rendered on the outside of the sphere, as we want to watch it inside a sphere. But where is our sphere? We need to have a sphere or a shader, it's called shader, to make our texture drawn inside of our sphere instead of outer one. We need to search a shader inside out Unity. And as you can see, we have this one, and we can just copy it. And let's create a shader. To create it, just right click, create and shader, and just use standard surface shader and just name it flip shader. And open this up and just delete all of their content and just paste from our internet found flip shader, and you can just name it a custom shader / flip normal, and we can just call it, change it to call back to make this material or this shader to render on the back instead of the front. And you can change the shader of this material by press the custom and flip normals. And is this finished? Oh, not. Sorry. So make it cool. Oh. And as you can see, right now, you can see our sphere is rendered on the inside. So let's disable this one. And when we press a play, now you have video 360 player inside your Unity. So that is how to create or make a 360 video player within Unity. So let's make this one is a little bit bigger, so you can travel around and you can see this one is 360 video. When you press play again, you can see the video is playing. Alright, that is for video player crash course using Unity video player. We already learned about how to play a video on the full screen mode, and on the 3D, which is we already learned about how to play or place our video within our TV 3D, and we already learned about how to create 360 video player within Unity. So the next one, or the last, or I mean, we have some times to cover. We have some, we have two topics left, but I think we don't have that much time left. So the next one we want to cover is how to create game objects from prefab. So, for example, let's leave this kind of, for example, plane. Let's just disable this for now, and let's get back to some plain normal video. I mean the old plain forest again, without TV and without videos. And as you can see, we still have our bear and our creepy deer still staring at us. Oh, I forgot to disable this rotate around, I think, and he's still following us wherever we go. Okay, the next one is we want to have some game object created or spawned in the real time. So for example, in the game, like for example Counter-Strike or other shooting games or VR experience, for example Call of Duty or Battlefield, a player can shoot something, right? A player can shoot a bullet from their gun, but it's not that every gun in their games is already placed on in their games. They just spawn the gun, they just spawn the gun, and then the bullet, spawn the bullets and shoot the bullets in the in-game or in real life or in runtime. So the needs or the steps that we want to create our bullets, for example, is we need to create a template of our bullets, and we want to spawn our templates more and more, one by one at a time, and just like that. So for if on the visualize mode, for example, we want to make the first thing. Let's say we have some bullets. For example, that's a capsule. Capsule is like a bullets, right? We want to let's rotate it like this and make it smaller. We want to have a kind of shooting ammo like this, right? Like shoot, like this, but we want to make it some kind of template. For example, we want to shoot this kind of capsule, or we can use it like a bullet. We want to shoot our bullets to some, for example, animal in it, to our deer, for example. Let's create just like that. The first thing, we need to have some script that handle our bullets movement. So let's just create the bullet script and place this bullet script to our bullets. I'm sorry, it's still loading up, and once it's finished, bullet, you can drag and drop, the bullet script to the bullets, and we can just make this one shoot out. So first thing first, the bullet movement is the same, right? Let's just ignore some gravity and hard physics stuff for now. But I'm sorry, the bullet movement is just moving straight point, right? From point A, for example, to point B, and then the movement of it is forward, right? So if you remember about our first script, is that we want to make our script move at some speed forward. So let's just make that transform and translate. Translate. And we want to make our bullets move forward. And since the capsule is actually like this, where's my capsule? Since the capsule is like this, a forward should be like this. But we want to shoot something like this. So it is, let's just play for now. If we press something like that, what happened is our bullets is kind of push down, moving at some accelerated speed. Let's just make it, let's make a variable speed, public float speed multiplier, and let's make it multiplier. Let's multiply our transform forward to our speed multiplier. And as you can see, after Unity compiles our script, we have a variable called speed multiplier, and you can just maybe have a little bit slower speed. And as you can see, when we press play, the script is moving but in the wrong direction. So it's easy, so let's just rotate it up to this one, like 90 and 180. And when we press play, you can see our bullets is kind of moving really slowly. And maybe we want to make it a little bit faster like this, or maybe 1.10 font, like ooh, yeah. It's fly like that. We shoot something right now, but we want, of course, to make this kind of functionality is running when we press some buttons, right? Like, for example, a mouse right click, or on the VR mode is like a tap of the cardboard buttons. So we need to have a bullets reference to the our player. So let's create real quick player script. Let's name it player, and let's make our player shoot the bullets when he or she press a button or left mouse button. The syntax is input.get mouse button down, and then the index of the mouse, since the left button is indexed as 0, you press it, or we input the 0 number on it. And we want to shoot the bullets. So what is bullets? Means bullet is just a game object or a script let's have a game object reference of our bullet. So let's just make our bullet right now is active. And for first time, we make our bullets non-active. So let's just drag and drop our player script and drag and drop bullets game object on it. So when we press play, we see this bullet is not running, or it's not moving from now because a bullet is still non-active. But as soon as we press left mouse button, you can see we press or we shoot some bullets. But we only have one bullet now, right? To create our bullets, we need to have a template game object called Prefabs. So let's create a folder called Prefabs and drag and drop our bullets in here. So as you can see, we have now a prefab bullets. So prefab is just like a template of our pre-made game, a 3D object or 3D game object. And this is ready for us to be used later on if we want to use this kind of bullets, right? So it is safe for us to now to delete the bullets, and instead of using the game object within the hierarchy, we want to have our bullets spawn. So instead of shooting the bullets, we want to spawn our bullets first. And to spawn it, we need the script called the function called instantiate. And we want to instantiate a bullet. And the first one, we need to define what is a bullet, which is it's just game object. And then what game object that we want to instantiate on. So the bullet is the game object that we want to spawn. And the return value of game instantiate is a game object as well. So we can just use game object and like spawn bullet equal game object. And then we can just spawn game object and make it active. So let's back in and go to our prefab and drag and drop our game object to it. And when we press save and we press play, as you can see, we can shoot our bullet infinitely now because we create a bullet game object from our project view to our scene. As you can see, when we press play, our bullets is more and more. We have a lot of bullets right now. So that is the prefab of that. And for performance cost, we don't want to have our bullets too much in our scenes, right? So we want to make sure we destroy our game object after, for example, 5 seconds it's spawned. So let's get back to the Unity, and when we press play, you can see when we press shoot, 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 and after 5 seconds our bullets become gone. It's just like that. So the next thing is that we want to instantiate our game object from some certain position. So, for example, let's see. If we press the buttons in here and, for example, we move our SEACC like this and we press click, the button is instantiating at some fixed position, right? And we want to shoot from our middle eyes or our middle screen. So how to do that? As you can see, we want to have some transform position and rotation that we need our bullets to instantiate on. So let's have a transform and let's say bullet spawn point, and we can modify the instantiate parameter to go something like this, because as you can see, we can instantiate game object and we can populate or input the vector of position, where is our game object or where is our bullets is spawned, and we can have the rotation of it. So the position is bullet spawn point then position, and the quaternion is bullet spawn point dot rotation. So if it's going well, hopefully we will have our shoot or our bullets shoot from our eyes. So how to do that? When you see bullet spawn position, we just need to drag and drop our main camera. And as we press play, oh, and then our shoot or our bullets is shooting from our eyes, but in a weird rotation or weird kind of rotation. I mean, yes, it is weird. So what is what's wrong with that? Because we have a bullet transform point using our main camera. So if we remove this piece of code, for example, like that, your bullet will be spawned or instantiated using this piece of information. So we want to make sure our bullets is shooting from our middle eyes. So that is the one that we want to achieve for now. So if you see our player, when we move around, this position and rotation is not changed. This GVR reticle is as well, but in the main camera it's moving. The rotation is kind of changed, so we need to have a position and rotation derived from that. So, but the problem is, if we spawn our bullets in our main camera or using the main camera, as you can see, if we have, for example, the same rotation as the camera, you can see our bullets rotation is like this. So we want to make our what can we say, our bullets, you can see, our bullets to kind of go this rotation, this like this one, right? This rotation is derived from the bullets itself. The X is 90 and then the Z is 180. So we want the position is, of course, the bullet spawn point, but the rotation, we don't want it to derive from the bullet transpoint itself. Bullet spawn point dot rotation. And then we want to define our bullet rotation. So transform the Euler angles to be moved from x plus 90 and the z plus 180. So the rotation, or rotate new vector 3 to 90, 0, and 180. Let's press save for now. Let's make it. Let's see some chat box for now. It's from Dendi Sabto Adi. It's he asked that if we finish yet or not, and then the spectator or the viewer is all of them is Indonesian. So yeah, actually I was asked from Simolec to present this lecture in English. So if you have some difficulties or you have some input to the Simolec, you can maybe just send it to them, maybe something like that. I'm sorry if you have some something like that, but if you have some maybe problem or have some question regarding Unity development, you can ask from the chat box. So let's get back from where we left. And when we press the buttons, oops, I'm sorry, the bullets need to run first. And as you can see, we shoot the bullets right now from our middle eyes. It's bullet. Okay, and then the last one that we need to talk about is about raycast, but I think our time is already up and we will cover the raycast maybe on the next course or the next session of our course on the Wednesday, and we will talk about raycast. And then the next of the part 2 of 3D interaction within Unity. So I think that is for today, guys, of 3D interaction in VR part 1, and then the next lecture course is on the Wednesday, and we will continue the 3D interaction in VR on that day. And if you have some question, please feel free to type on the chat box. Thank you. I think we don't have any further question, and then we have some question. I'm sorry I will read it out loud for you guys. Sir, can I have your email, please? We have some question and trouble during the practice. Thank you. Okay, you can contact me at aditya.pratama2910@gmail.com, and you can email me about your problem during development, and I will reply you as soon as I check my email. So, but if you want to have some more immediate reply, you can just hang out with me on my Facebook or LinkedIn. Okay, and then the next one is from YonTX. Mr. Adit, I am lastly to join. So how to insert a video? So just like we said, or just like we already threw from our tutorial, how to insert a video. So if you have a video in your computer, just drag and drop the video to the projects view. The step one is that. And then we need, or you need to have a video component like this one. So the more details about that, I think the CMOX or CMO staff will upload the online or the recorded version of this session, and you might watch that as well. I have understood what you've explained, but I need the video to practice it more, so I hope you upload it sooner. From SMK Nurul Jadid. Yeah, thank you for you guys to join these courses. And I think if and you ask about I need the video to practice it more. If you talk about this recorded session, yeah, we will, or the Simulec staff will forward it or upload it sooner, or upload it as soon as the video is up. So yeah, you can please just wait a little bit. And if you want to practice it more, but outside of this video course topics, you can just search online from YouTube or any others video server provider. For example, the one of the notoriously good is from YouTube, or maybe just like online course like Coursera or something like that. You can learn every object of Unity in that website. And then the last question is asking about, is Milia Beta already released? Yeah, actually Milia Beta is already released, but this is still on the closed beta, on the closed beta step. I mean, you can register to try the Milia Beta, but only some selected people that can access Milia for now, because the current state of Milia is beta, right? We still developing and bug fixing any error happen in the production. So I hope you guys can wait a little bit time for Milia to be accessible for everyone else. And by the way, thank you for your support, and with your support like that, asking about Milia, we will have some more spirit to make Milia done as fast as we could. And then the last one is, I just want to make sure next 2 days are going to be our last meeting, right? Last meeting, I think it is, yeah, for VR training 101 right now. The last one I think is on the Wednesday, but I might have wrong about it, but yeah, you can check. But I think the Wednesday is the last day of our online session. So yeah. Okay, guys, I think the time is up for now. Thank you for your question and your And we can and okay, the last question is, can you provide the link where we can find the whole app used? I mean, we can download it, complete one. The app, if you mean the app is Unity, you can of course download it on the resource and link that I attached on my presentation, and you can open it up as you might see when the video is uploaded by the Semalek staff. Okay, that's it. Thank you for today. See you guys on the Wednesday.